What's happening? I need this. Is it recording? Hope so. Okay. Part 3, solving polynomials. Numbers 13 and 14. I'll do 13, you do 14. Now I'm going to list out the steps because I can't show the calculator necessarily, but when solving polynomials, the first thing I should consider is what's the highest power. In this case it's 4. So this means I'm going to find 4 solutions. That's the fundamental theorem of algebra. 4 solutions. So in order to do that, the way we've learned it is that the step 1, I'm going to graph the polynomial in calculator. Calculator to find the real solutions. And you should know, hopefully by now, that the real solutions are where the graph crosses the x-axis. So if I plug that into my calculator, I should have done this beforehand to save time. 2x to the 4th minus 11x squared minus 63. And I watch it graph. If your window's off, you have to hit zoom 6 for standard viewing. I will draw a little sketch of what I see. It is something like 1, 2, 3, 4. So the graph hits, I see a line here at -3, and I see a line here at +3. That's all I see in my viewing window. But I know that then there's a solution at -3 and +3. So my real solutions in this polynomial are x equals -3 and +3. Alright, I am done with the calculator for now. That's step 1. Step 2 is then to synthetically divide both real solutions. Now, it does not matter which one you do first. If you do the math correctly, you should arrive at the same answer no matter what. But be very careful. Please remember your space holders. Space holders, you need to include a 0 whenever the power jumps over 1. I see here that the power of 4 goes to 2. They're missing a third power, so I'm going to need a placeholder in between 2 and -11. And here it goes from 2 to the constant term, so they're also missing the linear term x. So I'll need a placeholder between -11 and -63. I'll set up my synthetic division box. I'll start with -3 first. Again, it doesn't matter. I write 2, the first coefficient. Then I need a space holder because we jump over the power of 3. Then I'll write -11. Then I'll have a space holder again because we jump over the power of 1. And then -63. I have set my synthetic division box up correctly. I'm going to bring down the first term, multiply to the outside, add to the inside. -3 times 2 is a -6. 0 plus -6 is -6. -3 times -6 is positive 18. 18 plus a -11 is positive 7. -3 times 7 is -21. 0 plus -21 is a -21. And -3 times a -21 is a positive 63. Here's a checkpoint for you. How do you know you're doing it right? I will answer it. I know I'm doing it right because I got 0 from my remainder. Now I'm going to evaluate my other 0, which was positive 3. So, draw my box again. Positive 3 goes on the outside here. Still drop down the first term, 2. 3 times 2 is 6. -6 plus 6 is 0. 3 times 0 is 0. 7 plus 0 is 7. 3 times 7 is 21. Draw my remainder box. -21 plus 21 is 0. I didn't say this up here, but -63 plus 63 is also 0. I know I did that right because my remainder is 0. When you're doing this process, you should not get a remainder. If you did, that's a clue to go back and check your work. Alright, now I have to determine my new quadratic function. It's no longer a fourth power, it is going to be the greatest power of 2 because I synthetically divided 1, 2 times. Each time I synthetically divide, I lose a power. It started at the power of 4, now it's going to be the power of 2. So it's going to be 2x squared plus 0x plus 7. Pluses because they're positive. So I'm going to rewrite it nice. 2x squared, don't have to write 0x because it's 0, so it's just plus 7 equals 0. From here, I'm going to go ahead and solve it. In order to isolate my x, here, there's a couple things I have to do. First, I have to get rid of that 7, not by adding 7, by subtracting 7. Subtract 7 on both sides, it goes away there. I'm left with 2x squared equals negative 7. Then I have to divide by 2, because it's being multiplied to the x. So divide by 2, I get x squared equals negative 7 halves. And then finally, in order to get rid of that radical, or the power of 2, I need to take the square root. I square root both sides. Again, I can't take the square root of a negative, so my final answer, my final 2 solutions are going to be, let me draw an arrow here, x equals plus or minus. I need plus or minus because whenever you take the square root, you have 2 answers. I need an I because you can't take a square root of a negative, times the square root of 7 over 2. Now on your answer sheet, there's 2 of my answers, and then the other 2 are up here. But I need you to write all of them in the same place for my benefit. There are my 4 answers. And I've satisfied that because I was looking for 4 solutions in the fundamental theorem of algebra. Now, you try number 14. Give it a shot. First question you should ask yourself, how many solutions are you looking for? Oh, back to this answer here, down here, is different on the answer key that I gave you. Go with that answer there, the one I just found.